Hello, hello. My name is Dominic Thomas. I am a professor of information systems and security, and tonight or today or this morning or whenever you are watching this video, we are going to work through Module 2 of Python Absolute Beginner. So I will go ahead and, I should not launch Jupyter Lab. Many of you are probably using Jupyter Notebook, so I'll launch Jupyter Notebook instead from the Anaconda Navigator. There we go. And I'm going to find my code. So I'll go over to the Python teaching code here, and I'll open the Absolute Beginner, and then I'm going to open the tutorials for functions. And I know some people are having trouble with these videos loading, so why don't we go ahead and we'll work through a little bit here together, and that way you've got a walkthrough. So right off the bat, we can see that we're going to create a simple function. We're going to learn about return values, and we're going to learn about parameters and arguments. So there's some vocabulary there that we'll refer to once we do it. And we're going to begin with creating a function with a parameter. So there's a big idea about functions. There's actually a video up in D2L that you should go watch, probably right now before you go through this tutorial. But even if you've gone through the tutorial already, go back, watch that functions video, because it talks about some of these key issues. One of the first things to note here is that we've already been using functions. Functions are a way of taking code and containing it into a named rule set that you can then call when you need it. So there's some vocabulary, the word call. So now if I scroll down and I look here and I see print and I hit command return, I see that the notebook has run this function. This is called a built-in function. So up here you'll notice that it says built-in function. These are built into Python itself, and they're available all the time. So print is one of these functions. It actually has a definition in a file that comes with Python when you install Python, and that function definition has a few different ways in which it can be used. So we notice here, for example, you may not have noticed this before, but when you have a string or any kind of item, and then you put a comma, and then you put another item and give them both to a print function, it knows to take both of the items, it adds a space, notice that, where the comma was. It adds a space, and then it puts them together in the output. And here's another exciting thing. So notice here, if you do student equals age 17, student name equals Hiroto Yamaguchi, and then we go run this and see the commas there. So if I hit command return, it actually created a sentence out of that. Now I want to show you something different. We've learned a little bit about the print function and concatenating strings, or putting them together. Remember, this age here is actually, so if I do this, if I make this number 17 into a string, I can actually just do this. I can put a plus sign here, I can put a plus sign here, and I can rerun this thing. And what I want you to pay attention to is the spaces on either side of the 17 here. So when I run it, you see my spaces disappeared. So now when I'm testing, I realize, oh, I've got to put a space in. Okay, and now I'm going to run it again, and I got it. It worked. Now what happens if this isn't a string? Remember, a string is just text. So it was treating the 17 as text, but now that I've taken those quotes away, it's going to treat it as an actual number that can be used in math. And so now if I run it, I just got a type error. it told me I can only concatenate a string, not an integer, to a string. So now I've got a problem. Now I would actually have to type, oops, not int, I want to turn it into a string. So now I'm going to have to do something like this, oops, and that will force this integer to become a string at the time that I'm running the print function. So now I can run that. I'm going to hit command return, and now it looks good again. So can you see that the print function has a functionality that's actually a shortcut for doing all of this? I can actually just put that comma right here and this comma right here and take out this space. And I don't have to worry about converting my integer. I can just run it. I just ran it and I get the same result. So the print function has that functionality of converting things to strings if they are independent and separated by commas as inputs. So it's allowing you to give a whole bunch of stuff to the print function and it's printing it out for you. So that's how that function works. And it's got code in the definition of the print function to handle all of that. And you can see here, you can run this example. So you can put an empty line if you want by putting in an extra. So there are several things there. Arguments and parameters are worth talking about a little bit. In the definition of the print function, it allows you to put in an unlimited number of arguments, which means that the print function is defined with any number of parameters allowed. And then it will take all those parameters one by one and it will turn them into strings and put them into the terminal as defined. And so it's doing that. So the parameter is what was defined in the definition of the print function. But when we call the function here, that's when we talk about arguments. That's the thing we actually put into the function when we use it. So we didn't have to define the print function. It was already there, and we can just use it. Now we're actually going to define a function. So this is where this keyword def comes in. Now I want to remind you, so if we go back and we pick up our cheat sheet, so I'll go ahead and pull it up, and you may not have thought about it, but over here it told us that DEF, see it up here? DEF is a reserved word in Python 3, which means it has special properties. It's a magic word that can do special things, and what it can do is it can define a function. And there are some rules. So here are the rules. And that means we've heard and seen a little bit about indentation already, but this is super important. And remember, I mentioned a minute ago when we define the function, that's where we decide the parameters. We refer to them as parameters, they're labels. And so down here we can define a function called say hi. And to define it, we put the def keyword, we name the function. Names begin with lowercase words. And if we're going to separate words or have multiple words, best practice is to put an underscore, and then we put a colon. Now after that, when we add information to our function, it needs to have this indent. Everything indented under here contiguously will be part of the function definition. Python will understand that. So now I can do command return, and I've now got this function in memory. I know it's in memory because I ran it, and I see over here that the 9th thing run in the current notebook was this function. And it tells me the order. Now, if I really wanted to see the result of the function, I would have to call the function. So I'm going to come over here, and I'm going to do that. I'm going to Oop, no colon. I'm just going to call it. Remember, that's how we use the print function after all. We just use the name of the function and we put parentheses. And in the print function, we feed something to it if we want it to print that. If we don't feed anything to it, it will send a return to the output window. So I'm going to hit Command Return and look. So this here, I am calling the function. And up here is where I am defining the function. And now I've defined a function and called it. And because this was unindented, Python knows that the definition ended right there. And now it's going to use all that code to do something. So the nice thing about defining functions is that they create reusable blocks of code that we can then put into other places and use many times if need be. Here we can see a function that will automatically output the number 33. I ran this cell. Now let's say I go up here and I want to add another cell. So I can go back up to the top and I can say Insert, Cell Below. And I've created another cell, and I can actually 3. I can do that. And now I can call my function in another cell because it's already in memory. Remember I said you could reuse the code elsewhere? So now I can hit Command Return and I get my 33. So there's a lot you can do with functions. And when we call the function by name, you notice that it'll actually, if it's in memory, Python knows what that refers to. It goes back, finds it, and it runs it. Now these functions just print to the output terminal. This 33 is unusable in further calculations at this point because we're just printing it out to the output terminal. And you'll notice we can actually we already have these functions in memory. So I can comment this part out of this cell and it won't matter because they're in memory. So I can go Command Return and sure enough, Python already knows where all of these functions are. Print was built in and we didn't feed it anything, so it just gave a return. Say hi did what it does. 33 did what it does. Yell it function, if we had to define our own, what would we do? We'd use a def keyword. We would call it yell it, like that. And when you follow instructions, it says print the phrase with this extra thing at the end. Now notice it says define a variable called phrase and initialize with a short phrase. So it's telling me go ahead and say phrase. And a short phrase, well, hi is super short, so that's easy. And then yell it takes no arguments. So indented function code. So actually it's telling me inside of the function, it wants me to go ahead and define that. And then it wants me to print phrase plus an exclamation point, right? And then it says call yell it. So I'm just following those instructions and I'm going to hit return and sure enough, I see my hi with an exclamation point. See that? And so, and it tells you the tip, no indentation when you call the function, right? Because it's outside of the definition of the function. Now, down here we start to learn about parameters. I mentioned them earlier, but we can see this is an important built-in function called type. And it allows you to take any variable and see what it is. So I can find out if it's a string or an integer. Of course, we know that hello is a string, but now we can do something special with our yell this function instead of yell it. We can actually use a couple of built-in capabilities, and one of them is when we have a string, so back to our cheat sheet. Strings have something called methods. We'll learn about object-oriented programming later. But down here, we'll notice that there are string object methods, and one of these methods down here is called upper. You see that? So when you do .upper, it's like a special function that only applies to strings, and every string can do it. It will take the content of that string and make it uppercase. Isn't that interesting? So now I can come over here and I can see what's happening. We can define a function called yellThis that has a parameter called phrase, and that's going to rename whatever we feed it at call time to this name phrase. It's going to get relabeled so that we can consistently use it. And then whatever the phrase is, we're assuming it's a string. It has to be if this is going to work, or it'll throw an error. It will make that uppercase and put an exclamation point at the end. So when we call the function down here, the argument we're feeding to our phrase parameter is this string. It is time to save the notebook. So I'm going to go ahead and hit Command Return, and look at that. It did it. It made it uppercase. It put the exclamation point at the end. It did everything we needed it to do. Now, it did say here it's time to save the notebook, so I'm going to hit Command S and save my notebook. A default argument, so this is an interesting way to define your functions. If you want your phrase to be high by default so that people can actually run and call the function without having to define your parameter, without feeding it an argument, it will then default to high. So here you can see this function now, say this, it can be called with nothing, or it can be called with an argument given. Same thing as the print function, right? If you call print with nothing in it, it just provides a return. It skips a line. If you call print with some stuff in it, it puts that stuff on that line. So same thing, we've now created a default for the phrase parameter so that this default argument is put into the phrase parameter if the user does not put anything in there at call time, as we just saw. And so we could do that with yellThis. So your task, you can do this here. You can do it because we just went through all these pieces. And remember, getting user input is where you use this built-in input function. And when you get input, you want to grab that. So words to yell, I'll just do a little bit here. Words to yell, you want to capture your input result. And you want to write a prompt. That's what goes into the input function, is the prompt to the user, and you want to tell them what to do. So give me some words to yell, and I like to put a colon and a space so that it reads well, and I can test that. You see how it said give me some words to yell, and I can say hi, and because I didn't do anything else yet, it didn't do anything with it. But you really need to write your def statement and define your function up here, and then you're going to have to call it down here. So when you get that all right, it's going to run all the way through, and you're going to feed words to yell this variable to your yellThis function. All right? I think you can do it. So going on with functions, there's a difference between print and return, and this difference is quite important. So let's take a look closer here. Now here's type. So type tells us the type of an object. And I can run down here and see how this works. So for example, we can capture the result of the type function into an object type. And we can use a return. So return's another protected keyword. Whoops, it jumped on me. So if this happens to you, then you can actually just replay this this cell. I'm going to use command return, and it's going to come back. You see that? So sometimes if you double click, because the text is actually editable, it's a cell. If I double click, it opens it up, but then I can close it back by hitting I can play this cell. Just like you run a code cell, if you run a markdown cell, it will show itself again. And so now I can come down here and I can try this out. So here's a function, and this one says return double. So it's going to take the phrase and it's going to double it, and then I can capture. What return does, unlike print, is it actually takes that content and sends it back to your code so that you can capture it. Do you see how I made there's a new variable here, message 2 times? I'm capturing that back into a variable, a container, so that I can then reuse it down here. In fact, if I wanted to do it 4 times, I could do it even more. So we'll try that out, all right? So I'm going to go ahead and run this. I'm going to hit Command Return, and it says let's go, let's go. And check this out. What if we wanted to quadruple our message? I could actually go down here and do message double and feed it the doubled message. Now we've got a quadruple message, right? Let's try it. Command Return. Oh, look at that. Because we used the return, it worked. Watch this. What if I change this to print and I just print double? So now I'm going to print double. And now we're going to save it. I'm going to hit return. And I get an error. Do you see that? Unsupported operand for type none. So what happened? When we tried to capture the result of this function into message times 2. It didn't do that. In fact, it didn't return anything. It just dumped the result to the terminal, but it did not keep it in memory, which means we couldn't capture it into this variable. So when we ran the function right here, it printed to the screen, but what it returned was none. And so then we tried to use our function with none. And up here it tried to put none plus this space as a string plus none. And that's where this happened. Look, right here, it tells us the error was right here. It says it can't put together none and a string. Aha. So the return really makes a difference. If you want to use this content later and keep it in memory, you have to use return. So when I read my error, I see that problem and I can fix it. You've got to use errors to your benefit. I think with this much discussion, you can handle this next example. So return, think about return, run the example, and notice the type. So the type command tells us we've got a string. That's cool. All right, so it's returning a string from this function because it actually did type on the item that was returned. And if we were to switch this to print and hit run, it tells us that it's got trouble. Well, actually, I didn't put the parentheses in, so it didn't know how to feed it. So that's my fault. So I can see that in my error there, right? So I see my error and I fix it. And it tells me that the type of the result from this function is now none. So you can see the difference in how it changes things. Return versus print, quite important. And so if I do return, it actually preserves this thing in memory as a string. All right. Doctor title to a name. This is very similar to the yell this. So make doctors. I think you can do that. Task 4. Functions with multiple parameters. This is actually pretty straightforward too. You can define multiple parameters by putting a comma in your definition, and then you can do things with those. If you don't know what this .title is doing, take a look at the string object methods in our cheat sheet, and you'll see that it'll make uppercase the first letter of each one of these names, each of these periods, period 1, period 2. And you'll see what it does when you run the example. Make schedule. So here you can see how we could have 3 different periods, and then we could print out the schedule. So again, that's something I think you're ready for. There are a couple of issues here with sequence, the order the code is processed. So it's going to get processed from the top of the page to the bottom. You see that in the instructions here. And best practice is to define your functions after you've imported any libraries and defined any constants. You define your functions at the top of your code in a code file. So that's good to know, and just in terms of the right way to do things. But you also have to think about what that means if you try to call a function. So here, if we tried to call had available before we define had available, we're going to get an error, a name error, because the name is not defined in memory for Python yet. So there's an order in which things have to be in your Python file. And if they're not in that order, you can't actually use them. So this is really important, and you'll see that here. And so now you know how to fix this error. So if I come down here and I run this and I see name error, I know that I've got to take this code with the definition, and I've got to come up here before the call, and I have to define it now before the call, and I'll save and I'll hit Command Return, and look, I fixed my error. Errors are your friend. You want to be able to see a name error and know what's going wrong. So you can run this one at this point. I think you're ready. And as far as hard coding, so see here, had available green, this argument. So when possible, it's better to go ahead and feed a variable to a function when you can. And it's a little bit more advanced, but the idea is feed it color instead of the literal string green. That way later, if you need to have multiple colors in your online store, it'll be more maintainable. So there are some kinds of issues like that. Task 7 is very similar to had available. You can handle this too. I think with our in keyword, you're ready. And task 8, fix the error. Once again, I think you are ready. So have fun working through the functions module 2 of Python Absolute Beginner, and post any questions or issues, and we'll look forward to moving on to our next step.